Functions and graphs, bit of revision, a quick rundown of circles and semicircles. Okay, if we wanted to sketch this, you can see it's pretty similar to a circle. If we squared both sides, we would get y squared equals, and our squaring of this side would cancel out the square root really, and we would get 16 minus x squared. If we then added x squared to both sides, we would get x squared plus y squared equals 16. Now that is, if you remember your circles, that is a circle that has a center 0, 0 and a radius of 4. But we can't forget that originally, and I've drawn all over it so I'll redraw it here, our original version has a square root in it. Now if you think about it, a square root can't ever end up being a negative result, so y is only valid for positive or 0 values. So in the end, what I'm getting at is that we have a circle type shape, but only where y has positive values. And so we end up with this sort of situation where it's a semicircle just with the positive half of the circle being shown, and there's no surprise that our radius is 4 on that circle. That's how we think through the sketch there. Okay, this one has a big minus in front of it. So if this was looking at only positive values at first because of the square root, it's now looking at only negative values because of the big minus in front of it. And if we rearrange that, we would get a radius of 2 there. If we square rooted 4, we get a radius of 2. So this time it's got a bit of a circle shape to it, but we're only looking at the places where that circle has negative y values because of that minus there. And the radius there is 2, as I indicated. Now here's your basic circle, and your basic circle equation is x squared plus y squared equals r squared. So if we square root that 25, we get a radius of 5, and there's nothing else happening on the x's and the y's there, so that kind of indicates that the center of our circle is going to be at the origin with a radius of 5. So there it is in red there. So it matches up nicely with your basic circle formula there. When you do have extra things around the x here, then the negative version of what's in the brackets tells you about the center of the circle. This center of this circle can't be at 0, 0 because x isn't on its own and y isn't on its own, but it's going to have an x value of -2, the opposite of what's in the brackets, and a y value of 3. That's going to make up the center of our circle. And we said that r squared was the usual general form of a circle, so our radius is going to be the square root of that, or 2. So we're looking to draw a circle with the center at -2, 3, and a radius of 2. Let's see how that works. So yeah, the center is -2, 3, and a radius of 2. So from there we go across 2 in each direction really to check the radius out if we draw it correctly. So it's gone down 2, across 2, up 2, and to the left 2 from the center in every case there. So that's how we think through that. It looks pretty complicated, but if we take the opposite of the values in the brackets, that creates our center, and if we square root that, we get our radius. So that's the clues for figuring out how to sketch a circle there, even when the center of the circle isn't at the origin. That's a few quick reminders of circles and things to do with semicircles. Thanks for listening. Catch you next time.